For this video, I'd like to talk about how to evaluate composite functions. So in these problems, you're going to be given two or more functions and essentially asked to put one function inside of another. So the first thing we need to get used to is this notation. So one way of seeing it, you'll see this kind of fog looking notation. This just means f of g of x. Now another way to write it, and honestly this is my more preferred method of writing it, is just putting g of x on the inside of f of x. Now you could see it with multiple letters, like it could be f of g of h of x. And again, I like to write it with kind of these nested functions, where f is the outermost, and the one closest to the variable, that's your innermost function. So you have f of g of h of x. So it's a function within a function within a function. Likewise, this one is a function within a function. So what we need to do is essentially figure out what the inside function is first, and then whatever that value is, plug it into our outside function. So we have this, let me rewrite it as f of g of x, f of g of 10 is what we're trying to find. And rewriting it with this notation, we have f on the outside and g of 10 on the inside. So the one closest to your variable, your number, is the innermost function. That's the function you want to evaluate first. So always start on the inside, figure out what g of 10 is first, and then whatever that is, plug that into your function f. So we need to find g of 10. So let's start there. Actually, let me change colors here. We'll use blue. So g of 10, I go to my function g, and I plug it in anywhere I see an n, I replace it with 10. So I get 10 squared minus 10. So that's 100 minus 10, which is 90. So I figured out what this is, and now I'm going to replace it with 90 because g of 10 equals 90. So I have f of 90, since these are equivalent, and I could just make that substitution. Now I just want to plug 90 into my function f. So I have the square root of 10 times n, which is 90, or the square root of 900, which is 30. So our answer here, when plugging 10 into g and then plugging that output into f, we get 30 as our final output. So let's do a few more of these just to get a lot of practice. So this one already starts with the preferred notation, or at least in my opinion. But we could have also seen it as g of f of negative 2. Just to get used to both notations, because you never know, you will see both of them. So with this problem, we again want to start on the inside. We want to evaluate f of minus 2 first. So we're going to do that up here. And f is a function of a, so anywhere I see an a, I'll replace it with negative 2. So we have minus 2 plus 2 squared. Well, this is just 0. So I get 0 squared, which is 0. So I figured out what this is. This is equal to 0. And now I'm going to replace it. So now I want g, instead of f of minus 2, since that's equal to 0, now I want g of 0. And plugging in 0 to this function g, I get 5 times 0 plus 4. So that's 0 plus 4, which is 4. So after evaluating these composite functions, starting with f of minus 2 on the inside, and then figuring out that was 0, and plugging 0 into g, we end up with an output value of 4. So let's keep going. So this one's a little bit different. Now we've got to find the mistake in the work. So we have f of x and g of x, and we're trying to evaluate f of g of minus 4. So the correct way would be to start on the inside and evaluate g of minus 4 first. So plugging in g of minus 4, so it should be 5 minus negative 4, but it's not. So when we plug in g of minus 4, it should be square root of 5 minus x, and x is negative 4. So that's 5 plus 4, which is root 9, which is 3. So instead of getting 1, you would get a value of 3. So step 1 is where the mistake was. Now, once you do get that value, instead of placing 1 in here, you place 3 in there, square it, you get 9. 9 times 9 is 81. So your final answer should be 81 here, but it's choice A. If we look at the rest of the options, you can see that g of minus 4, it's not 1, it's 3. And let's do one more, where we have g of m is m cubed, and h of m is this rational function. And so we want g of h of 6. Let me rewrite that. G of h of 6. And in the alternate notation, g is the outside function, h is the innermost one. And so we need to figure out what h of 6 is first. So I'll do that over here. And we get 6 squared over 6 plus 3, which is 9. So you get 36 over 9, which is 4. So this will be replaced with 4. And we have g of 4. And so we plug in 4 to our function g. And so we're cubing 4, which is 64. So our final answer for this problem, plugging in 6 to this composite function, gives us a value of 64.